So how to construct three-dimensional crystals using two-dimensional square close packed layers. In this, in the last class we discussed it's called if you arrange these layers one over another, you will get three-dimensional crystals, right? If you arrange the layers, okay, in such a manner that one layer should eclipse the other layer, right? If you arrange it like AAA type layer, then that crystal, that 3D crystal, you will get a 3D crystal. That 3D crystal consists of simple cubic unit cell. I have told you. Okay, if you arrange these layers, that is square close packed layers, one over another in such a manner that, okay, one layer atom should eclipse the other layer atom, right? If you arrange like that, you will get a three-dimensional crystal. That three-dimensional crystal consists of simple cubic unit cell. In simple cubic unit cell, each atom touches the surface of the 6 adjacent atom. Therefore, coordination number, right, in the case of simple cubic unit cell is 6. Right? So this is the information you should keep in mind for this construction. And we have one more arrangement here. Listen, suppose you take a two-dimensional square close packed layer. Let me show you a layer here. These are all identical atoms. Just for understanding purpose, I'll take crystal with the identical atoms, right? So let me draw square close packed layer. Okay, let us consider this is one square close packed layer, two-dimensional layer. Okay, this is one layer. Now listen, in this arrangement I have told you, if you place another layer over this, right, and if the top layer atom exactly eclipses the bottom layer atom, then you will get AAA type arrangement. Okay, for that what you have to do, you have to place the top atom exactly on the bottom atom, which is less stable arrangement I have told you. Now what I am going to do, I am going to place the atom right in this place. Students, just concentrate on this place. If you bring 4 balls close together, you will get a depression at the middle. Okay, there's a depression. Now I am going to place the second layer atoms on the depressions of the first layer. Okay, I am placing the second layer atoms right on the depressions of the first layer atom. Okay, yeah. So I'll place another atom here. I'll place another atom here. I am placing the atoms on the depressions of the first layer. Right. So if you place it like that, this layer, the second layer, is also a 2D layer, a two-dimensional square close packed layer. But now the second layer atom or the top layer atom does not coincide with the first layer atom. It does not coincide with the first layer atom, which means if the first layer atom, right, is A, then the second layer atom supposed to be a different layer, so which we represent as B. Okay, so if you arrange the layers like this, first layer is A, second layer is B. See what I am doing, I'll repeat. You keep the first layer and place the second layer atoms, okay, on the first layer such that the second layer atom should sit in the depressions of the first layer. Okay, what is depression? What is meant by that? Listen, if you join 4 balls like this, this midpoint, okay, just imagine you take 4 balls and bring them closer and keep it like this. then you'll get a depression at the middle, right? If you place the second layer atom, right, on the depressions of the first layer, you will get an arrangement called a AB arrangement. Now what I'm going to do, I'm going to place the third layer atoms on the depressions of the second layer atom. Students, it's very, very important. Observe this carefully. Okay, I'm going to place third layer atom on the depressions of the second layer. Listen, here you can see the red color circles, right? Red color circles. Now if I place an atom at the center of the red color circles, that atom will coincide with the first layer atom. See, in the depression there is a blue circle. It's somewhat difficult to see, but you try to imagine in this way. Okay, I am keeping first layer atom and I am placing second layer atoms on the depressions of the first layer. Then I am keeping third layer atoms on the depressions of the second layer. If you do so, what will happen? The first layer atom and the third layer atom will coincide. Okay, third layer atom eclipses the first layer atom. Therefore, if first layer atom is A, if first layer is represented as A, second layer as B, then third layer will coincide exactly with the first layer. So I'll represent third layer as A. So I'll get, if you do like this, I'll get an arrangement like this, AB, AB, AB type of arrangement. Okay, so it is very simple. You take two-dimensional square close pack layer and place the layers. If you place the layers in AAA type manner, you will get a 3D crystal. That 3D crystal consists of simple cubic unit cell, right? If you arrange the two-dimensional square close pack layer in AB manner, okay, you will get AB type of arrangement. This will give you a crystal. Right? Students, just imagine here, this is first layer atom. In first layer we have 4 balls. In the second layer I have a ball at the depression. Third layer will coincide with the first layer. Okay, third layer will coincide. So in the third layer I'll place 4 balls like this. Listen, the bottom 4 balls forms the first layer. The top one, this middle ball forms are the atom of second layer. Now I'm going to place third layer atom over this. Third layer should coincide with that, with the first layer. If you do like that, you will get an arrangement which look like body center cubic unit cell. Okay, let me show like this so that you can easily understand. See, I'll take a cube. Let me draw like this. I'll place 4 atoms here. Listen, in this representation, it looks that these atoms are not touching each other, but actually in the crystal they are touching each other. Okay, assume that this is the let me draw here. This is the first layer. Okay, the bottom one is the first layer. Students, observe this carefully. These 4 atoms forms the bottom layer. These 4 atoms, right? 1, 2, 3, 4. These 4 atoms forms the bottom layer. Right now, I'll place an atom at the middle. Okay, at the middle of the unit cell. So this is the second layer atom. This is the second layer atom. Okay, so second layer atom exactly present at the depression of the these 4 balls. And third layer atom, this is third layer atom, these 4, 1, 2, 3, 4. These 4 atoms forms the third layer. Third layer exactly coincide with the first layer. Students, are you able to follow this? Any difficulty in this?
No, sir.
Yeah. So this is first layer, and this is your second layer, and this is the third layer. Okay. So for third layer and first layer, the atoms are coincide. They eclipses each other. Therefore, I can say if first layer is represented as A, third layer should also be represented as A. Second layer is different. Therefore, I am representing that as B. Therefore, I'll get an arrangement which looks like AB type of arrangement. So the point is this: you take two-dimensional square close packed layers and arrange the layers in AB type manner one over another, you will get a crystal. That crystal consists of body centered cubic unit cell, BCC. Body centered cubic unit cell. Okay, in body centered cubic unit cell, listen, the top 4 atoms and the bottom 4 atoms are touching the middle atom, are touching the surface of the middle atom. Therefore, in BCC, coordination number is 8. In body centered cubic unit cell, coordination number is 8. Okay, remember this is very, very important. So I took 2D square close packed layers and I have formed 3D crystals. I have formed two different 3D crystals. One 3D crystal has AA type arrangement of layers, which will give you simple cubic unit cell whose coordination number is 6. In the last class I have told you this arrangement is very, very less stable. So in the periodic table, right, only the element polonium exists in a simple cubic manner, right, because it is a very, very less stable arrangement. Okay, because you are placing one ball over another ball. Okay, you know, well, if you keep one ball over another ball, it will slip down, right? So that is an unstable arrangement. Okay, whereas this arrangement, BCC arrangement, body centered cubic arrangement, so this arrangement is somewhat stable, right? Somewhat stable compared to the 2D. Okay, it is somewhat stable, right? So this is the point you should keep in mind. Next. Okay, here listen students, these 4 balls, listen, the way that I drawn here, right, actually in the crystal, right, they are very close but they are not touching. They are not touching actually. That's the point you should keep in mind. Okay, these 4 atoms are very close, they are not touching. Whereas the middle atom touching the surface of these 4 atoms. Similarly, the middle atom touching the surface of these 4 atoms. This is how the BCC arrangement looks like. Okay, and coordination number is 8. Usually in the periodic table, alkali metals, alkaline earth metals, right, not all, most of the alkali metals and alkaline earth metals, right, they usually exist in BCC type crystals. Okay, those crystals has BCC, those crystals have BCC unit cell. Okay, so using 2D square close pack layer, we can form 2 different types of 3D crystals. Okay, one crystal consists of simple cubic unit cell, the other crystal consists of BCC unit cell. When you will get simple cubic, if you place the layers as AA, you will get simple cubic unit cell. If you place the layers as AB, you will get BCC layer. In BCC, coordination number is 8. Okay, yeah. Any doubts, students, up to this? If you find any difficulty, you tell me.
No doubts, sir.
Right. Now we'll go to the next type of arrangement called construction of 3D crystal using 2-dimensional hexagonal close packed layers. Okay, let me write here. So the second way of arrangement, you take 2-dimensional hexagonal close packed layers. Take 2-dimensional hexagonal close packed layers and form 3D crystal. Okay, yes, here also you will get two different types of arrangement. Let me show the first arrangement. Okay, what I'm going to do, I'll take an hexagonal layer. Okay, let me show you a layer like this. Yeah, so this is the first layer. I'm drawing the hexagonal layer now with the red color marker. Oh, I'm sorry. we should place it in the depressions of the first row. Okay, let me draw like this. Students, you have to observe this carefully. Okay, so this is the first layer. This is the first layer. Now what I'm going to do, let me represent the first layer as A. Now what I'm going to do, listen, if you observe this layer carefully, you can see two different types of depressions. Okay, what are the two different types? Students, observe this carefully. The way I have drawn, okay, let me draw a little bigger here so that you can easily understand. Just for understanding purpose, I'm drawing this. Draw a little bigger. Okay, listen, students. See, in this arrangement, here I have depression. This depression looks like a triangle of this type. I just call this as an upward like triangle. Okay, this top face is for me it is looking it is facing upward, so it is upward like triangle. And this triangle, let me show you here. This triangle, just observe this. Here I have depression, and this depression looks like a triangle. That triangle looks like a downward type triangle. Okay, let me take this as A depression, and I'll represent this as B depression. A, small b represent the depressions. So in the hexagonal close packed layer, I have two types of depressions, A and B. Students, don't confuse with this. This represent the layer. Okay, this small b represent the depressions. Now in the two-dimensional hexagonal close packed layers, we have two types of depressions. Right, now what I'm going to do, I'm going to place the second layer over the first layer in such a manner that the second layer atom, okay, should sit on the first layer, okay, with the one type of depression, say A type of depression. Okay, so A type of depression, let me place it here, one atom here, one atom here. I'm placing only on the A type of depressions. If you place it like this, I'll get a second layer. I'm placing only on the A type of depressions. Okay, by observing this structure, okay, it is very difficult to imagine, but you can use this one, and you can imagine what I'm trying to say. You have to place the second layer atom only on the A depressions. That's all. Don't put it on B. Okay, so you take the first layer and see wherever A depressions are there, small A depressions. Place the second layer atoms on the small A depressions alone. Okay, if you do that, you will get an arrangement like this. Now what I'm going to do, I'm going to place the third layer. Okay, I'm going to place the third layer. Listen, if you observe this arrangement, see here, I have blue circles. This point is actually look like a B type of depression. B type of depression on the second layer. Students, just focus on this place. This point is the B type of depression in the second layer. Exactly below, I have an atom at the first layer. So if I place, listen, see what I did. I'll write so that you can easily understand. In first layer, okay, there are two types of depressions, A and B. There are two types of depression. I'm placing second layer atoms. Second layer atoms are placed only in A depressions. Only in A depressions. So I have A type of depressions. I am placing the second layer atoms only on the A type of depressions. Okay. Then I am placing third layer atom. Third layer atoms are placed. Third layer atoms are placed, right, only on B type of depression. Only on B depressions. B depressions of second layer. Here I am placing only on A depressions of first layer. Listen, first place the first layer, then place the second layer atom on the A type depressions of the first layer. Then place the third layer atom on the B type depressions of the second layer, If you place it like this, listen, first layer and the third layer will coincide with one another. Or you can say third layer atoms eclipses the first layer. Okay, listen, if you draw and see, you can easily identify that in the second layer, the B type depression, this is B type depression, the B type depression exactly below, I have an atom of first layer. Okay, therefore, if you place the third layer atom on the B type depressions of second layer, that will coincide with the first layer. Okay, so that's very, very important. Keep this in mind. If you do like this, you will get an arrangement. So if first layer is A, the second layer is different. So I can call second layer as B. Third layer will coincide with the first layer. Okay, third layer will coincide with the first layer. Therefore, I'll get an arrangement. It looks like AB, AB, AB. Right? So you can say simply like this. You take two-dimensional hexagonal closed pack layer and place one layer over another in such a manner that, okay, it should follow this arrangement, AB, AB, AB type of arrangement. Simple. This will leads to a crystal. You'll get a 3D crystal. That 3D crystal consists of simple hexagonal, AB, AB type of arrangement. Third layer will coincide, right? So yeah, you'll get simple hexagonal unit cell. Okay, so you'll get a 3D crystal which consists of simple. Let me write here. Consists of simple hexagonal unit cell. Student, is it clear? Any doubt? Is this clear?
No doubt, sir.
Yeah. Okay, if you arrange two-dimensional hexagonal closed pack layer one over another in such a manner that if you get AB, AB, AB type of arrangement, that arrangement will give you a three-dimensional crystal. That crystal consists of simple hexagonal unit cells. Simple. And here if you observe this carefully, listen, in this arrangement, this let me show you the next page. I like to show coordination number, right? That's all. So let me take. So this is the first layer atom. Let me draw the first layer atom like this. Assume that this is the first layer atom. Okay, first layer atom. Now I'll draw the second layer atom over this. Second layer atoms are placed in the A depressions, right? This is A depression. I'm placing an atom here. I'm placing an atom here. And I'm placing another atom below. Okay. Now we should keep third layer atom. Third layer atom should coincide with the first layer. Okay. Now in this arrangement, see this atom in the first layer, okay, the atom which is present at the middle of the first layer, right, which is touching the 6 atoms, okay, on the same layer. Okay, see what I'm trying to say? In the first layer, the middle atom of the first layer, this is the first layer. Okay, first layer atom, the middle atom touching the surface of the 6 neighbor atom on the same layer, and 3 neighbor atom on the top layer. Similarly, you will have 3 neighbor atom in the bottom layer. Students, very, very, very important. This is first layer. Okay, if I take this as first layer, or you can say you take this as second layer, so that you can easily understand. This is second layer, and this is third layer, and assume that I have a bottom layer which is below, which also has the same type of arrangement like this. Now in this case, the middle atom touching the surface of the 6 neighboring atoms, and we have 3 more atoms on the top and 3 more atoms at the bottom. All these atoms are touching the surface of the middle atom. So what's the coordination number? Anyone? listen, in the middle layer, okay, what I'm saying here is middle layer. The middle layer in which the central atom touching the surface of the 6 atoms in the same layer and touching 3 atoms at the top. Similarly, 3 atoms at the bottom. I didn't show the bottom layer here. Okay, just imagine like that. So what's the coordination number? Students? In the same layer, 6 atoms. Above 3, below 3. What's the total?
12, sir.
12, that's all. Good. Coordination number for simple hexagonal unit cell, right, are crystals that obtained by arranging hexagonal closed packed layer in AB type manner. You will get coordination number as 12. Okay, so let me repeat again. Listen, you take two-dimensional hexagonal closed packed layers, place the layers one over another in such a manner that it should give AB type of arrangement. If you place the layers like this, you will get a 3D crystal. That 3D crystal consists of simple hexagonal unit cell. That 3D crystal is called as, let me write here. Okay, so you will get AB type arrangement that leads to a 3D crystal. That 3D crystal consists of simple hexagonal unit cell. That 3D crystal is shortly called as hexagonal close packed crystal, HCP crystal. HCP means hexagonal close packed crystal. HCP means hexagonal close packed crystals. Right? Students, are you able to follow this? Any doubt? Any doubt up to this?
No doubt, sir.
Okay, ma. Just remember this. Right? If you arrange it in AB type manner, you will get a 3D crystal. That 3D crystal is called as HCP crystal, hexagonal close packed crystal. And what is the unit cell present? Simple hexagonal unit cell. Okay. Now, we have one more arrangement here. Let me show you in the next page. Number 2. Okay, you take two-dimensional hexagonal close packed layers. Okay, and place the layers in such a manner that, let me draw here. So this is the first layer atoms. Yeah, I'll show like this. This is the first layer atom. I'm just drawing roughly. Okay, first layer atom. So in the first layer we have two types of depression. I have told you. This is A type depression, which looks like downward like triangle, and here I have B type depression. Okay, this type of depression I am representing as A type depression. This type of depression I am representing as B type. Okay, what I am going to do now, this is the first layer. Now I am placing the second layer. Second layer atoms are placed on the A type depressions. On the A type depressions of first layer. Okay, so this is an A type depression A. This is an A type depression. This is an A type depression. I am placing the atoms only on the A type depressions. Okay, if you place the second layer atoms on the depressions of A type, okay, you will get the second layer. If I represent first layer as A, second layer atoms are not coinciding with the first layer because you are keeping on the depressions. Therefore, second layer is a different layer. Let it be B layer. Now, I am going to place the third layer. Third layer atoms are placed on the depressions of, on the A type depressions. on the A type. See, let me just draw and show you so that you can easily understand this. Observe this carefully, which is very important. See, I'm placing the second layer now. I'll place one atom here. I'll place one atom here. I'll place one atom at the downward place. Okay, place one atom here. I'll place one atom here. I'll place one atom here. Okay, I place the second layer atoms. In second layer, there are two types of depression: A type depression and B type depression is there. Listen, now I'm not placing the atom in the B type depression. I'm going to place the atom in the A type depressions of the second layer. If you place the atom here, that atom does not coincide with the second layer as well as with the first layer. You just draw and check whether you can understand this or not. Okay, you just draw and find out. Okay, it's very simple actually. So what I'm saying is, I'm placing the third layer atoms on the A type depressions, on the A type depressions of second layer. What is the difference between the previous one and this one? Listen, in the previous one, we place second layer on the A type depressions of first layer. We place third layer on the B type depressions of second layer. Okay, if you do like this, you will get AB type arrangement. But if you place the third layer atoms also in the A type depressions of second layer, I am placing the atoms only on the A type depressions. Okay, fourth layer also on the A type depressions. Okay, which leads to a crystal, which leads to a structure which looks like this. A type, first layer is A, second layer does not coincide, so B. Third layer also does not coincide, so it is C. Whereas fourth layer will coincide with the first layer. Then fifth layer will coincide with the second layer. Okay, so I'll get an arrangement which looks like ABC, ABC, ABC. Okay, so you take many layers, many layers, and place the layers in such a manner that, okay, we should get ABC, ABC, ABC type of arrangement. If you place the layers, okay, in ABC, ABC, ABC manner, you will get a 3D crystal. You will get a 3D crystal. That 3D crystal is called cubic close packed crystal, CCP. Cubic close packed crystal. Okay, this cubic close packed crystal consists of face centered cubic unit cells. Students, very important. Okay, if you place the layers one over another in such a manner that if you get ABC, ABC, ABC type of arrangement, that leads to a 3D crystal. That 3D crystal is called as cubic close packed crystal, which consists of FCC unit cells. Okay, are you able to follow, students? Any doubt in this? Hello, students, are you able to follow this?
Yes, sir.
Okay, yeah. So we are placing the layers. If you place the layers in this manner, okay, place the second layer on the A type depressions of first layer, place the third layer atoms on the A type depressions of second layer, place the fourth layer on the A type depressions of third layer. So if you place the top layers, okay, only on the A type depressions, you will get ABC, ABC, ABC type of arrangement. ABC, ABC, ABC type of arrangement will give you a 3D crystal. That 3D crystal is called as cubic close packed crystal. What's the name? It means cubic close packed crystal. Cubic close packed crystal, simply called CCP. CCP crystals consist of FCC unit cell. Okay, yeah. So try to remember all this information. This is regarding close packing in crystal. Now let me summarize whatever we discussed today. Then I stop. Whatever we discussed under close packing of crystals. Okay, yeah. See, using 2D layers, we are forming 3D crystals. Okay, just the idea, right? First, we took 2D square close packed layers. 2D square close packed layers. layers of crystals. Okay, using that we formed 3D crystals, three-dimensional crystals. Okay, CRY crystals. We form three-dimensional crystals. In this, if you arrange the layers as AAAA type, okay, which means one layer atom should coincide with the other layer atoms. Okay, if you place the layers as AAAA type, that leads to a 3D crystal, right? That 3D crystal, you will get a 3D crystal which consists of simple cubic unit cell, and the coordination number here is 6. You will get a simple cubic crystal and coordination number is 6. Instead of AA type arrangement, if you arrange the layers as AB, 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 okay, if you arrange the layers as AB, 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 you will get a 3D crystal. You will get a 3D crystal which consists of body-centered cubic unit cell. Body-centered cubic unit cell, and in this case, coordination number is 8. Okay, now if I take 2D hexagonal close packed layers, okay, and if you form 3D crystals by placing these layers one over another, okay, you will get 3D crystals. In this 3D crystal, we have two types. If you place the layers as AB, 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 AB like that, you will get a 3D crystal. That 3D crystal consists of that 3D crystal is called as hexagonal close packed crystal, HCP crystal, which consists of simple hexagonal unit cell, okay, simple hexagonal unit cell, and coordination number here is 12. Okay, then we have one more type. Let me write in the next page. Okay, if you arrange, I'll write here itself. If you arrange the layers as ABC, ABC, ABC like this, ABC, ABC type of arrangement, you will get a 3D crystal. That 3D crystal is called as CCP crystal. CCP means cubic close packed crystal, which consists of FCC unit cell. Okay, CCP crystal, cubic close packed crystal, consists of FCC unit cell, and here also coordination number is 12. Students, here also coordination number is 12. Okay, always hexagonal close packed layers, okay, when you arrange them in ABAB manner or ABC ABC manner, you will get coordination number as 12. Okay, so these are the things you should keep in mind, right? Is there any doubt, students?
No doubt, sir.
Okay,
No, sir.
right, ma. Yeah. So I stop here. We'll continue this in the next class. If you have any doubt, meanwhile, you can post messages, right?
Thank you, sir.
Yes, ma. Thank you.